Hi everyone. So now we will continue with chapter 4 for subtopic 4.3 orbital overlap and hybridization. At the end of the lesson, you should be able to draw and describe the formation of sigma bond and pi bond from overlapping of orbital and explain the formation of sigma bond and pi bond in a given molecules. According to the valence bond theory, a covalent bond is formed when two neighboring atomic valence orbital, like this, overlap with each other. Therefore, they will form a covalent bond, means they are sharing the electron. The valence bond theory and molecular orbital theory explain why and how the electrons are shared between atoms, and you will form covalent bond from this sharing. The overlapping contain a pair of electrons with opposite spin. Okay, so means in here, the hydrogen will give one electron, and for fluorine, it will contribute one electron. Okay, so the sharing of electron we always represent by drawing the opposite spin of electron. The valence bond theory is based on the four postulates. So the first postulate that you need to know is a bond is formed when atomic valence orbital overlap with each other. Let's see the example for hydrogen molecule H2. So, did you still remember hydrogen? You have one electron in one s orbital. So, one s is shape untuk s orbital is sphere. Okay, so when you are combining two orbital here, you will get overlapping, which in this form. So the first for the orbital, one s orbital with one single electron will overlap with another s orbital of hydrogen atom, and the electron will pair up like this, okay, with opposite spin. Okay, so for the next example, if you have hydrogen fluoride, the overlapping is between s orbital and p orbital. So the overlapping will be this form. Okay, but later I will show you how to draw it. Okay, so if you have two type of p orbital like this, okay, one p orbital for fluorine and another p orbital for another fluorine atom. So for this molecule, it is F2 molecule. Okay, so the overlapping will be in this form, which is the overlapping is end to end, hujung ke hujung. And if you have another p orbital with different orientation, okay, you will have the overlapping of side by side, sebelah-sebelah, like this. Okay, normally this is for sigma bond. The first one is for sigma bond. And the next example here in purple color, this one is for pi bond. Okay, so we will see in further when we go through a few examples of molecule. The next postulate is overlapping orbital contain a pair of electrons with opposite spin. So when you want to indicate the electron, the pair of electrons, you must draw in one pointing up and one pointing down. So it must be opposite spin. The third postulate is electron density concentrates higher between bonded atoms. So mean when you have overlapping in the middle here, between atoms, okay, the electron density will be higher in this region. Next postulate, the strength of covalent bond is proportional to the area where the atomic orbital overlap. So means if you have larger overlapping area, the stronger the covalent bond. But you just need to focus in your syllabus, you just need to focus on postulate 1, 2, and 3. Mainly we will focus on postulate 1 and 2. So there are two types of bond. The first one is sigma bond and the second one is pi bond. Let's look at the first type of bonding, sigma bond. It is a covalent bond produced by end-to-end overlapping of orbital on the neighboring atom. So there are three types of sigma bond. First, overlapping of two s orbital. Okay, so this is the example. So this is the example of one s orbital that overlap with another s orbital. So you will form sigma bond. The next example is the overlapping of s orbital and p orbital. Therefore, you will form sigma bond here. And the third type of sigma bond is the overlapping of one p orbital with another p orbital here. So you will form sigma bond in the middle here. Okay. So let's look at the first example. Example 1, you have hydrogen molecule H2. So for this example, you have one hydrogen that will bond with another hydrogen. So I'll just label this hydrogen A and hydrogen B so that you understand that I am referring to two hydrogen atoms. So for each hydrogen, you write the electronic configuration. So write in orbital diagram 1s1 because you have one electron in hydrogen atom. Same goes to hydrogen, the second hydrogen. You have 1s1. Okay, so one electron from hydrogen A will be given to be shared here, in between here, with one electron from hydrogen B. So that is why you can form sigma bond here. So how to show the overlapping? Okay, still remember s orbital, the shape is sphere. Okay, so draw one sphere and make sure it is big and clear enough. So label with hydrogen. So this is hydrogen A, and then so I'll just label it for you to see it clearly and understand the drawing. Okay, so hydrogen A, you have one electron. Okay, so label the orbital. It is 1s orbital. So it will overlap with another s orbital. So I'll just draw this one for hydrogen B, I'll draw it in blue lah. Okay, so that you can see clearly. So draw another 1s orbital, and it is hydrogen B orbital, and pair up the electron with spin down. Okay, so the overlapping here will give result to sigma bond. Okay. Next, let's have a look at the next example, hydrogen fluoride. So for hydrogen fluoride, you will have this structure hydrogen that will form a covalent bond with fluorine. Okay, so the covalent bond here is sigma bond, so label here. You are forming sigma bond. Okay, write the electronic configuration for hydrogen atom. Okay, you have hydrogen atom 1s with 1 electron. Okay, so next I will write for fluorine. So fluorine you have for fluorine you have 1s2, 2s2, and 2p5. 1, 2, 3, 4, 5 electron. Okay, this since overlapping, it will involve the valence electron. So you use the technique that I asked you. Okay, draw the curve to separate the first shell and then the outermost shell. So means your valence electron is in 2s and 2p orbital. You have 7 valence electron. Okay, so why is this important? Later when we come to a more complicated molecule, and for hybrid, okay, it is important for you to write and identify the valence electron. Okay, so for this case, hydrogen fluoride, so if you want to form one bond, means you need 2 electron. Okay, since it is sharing of electron, means you need 2 single electron. Okay, 1 single electron from hydrogen and 1 single electron from fluorine. So do we have the single electron? Okay, here is the single electron. So first, 1 electron from hydrogen, okay, that will be shared with 1 single electron from fluorine. So now you can form 1 sigma bond here lah. Okay, how we will show the overlapping? So I will draw the first one, the s orbital. So this is for hydrogen. So you have 1 s orbital here and with 1 electron. Okay, so for the next atom, fluorine, okay, since this is valence, to show the overlapping of the valence electron, and you can see the single electron here, I highlight in this green circle. Okay, so this one single electron is in orbital 2p. Okay, so that is why, okay, did you still remember p orbital, you have the shape of dumbbell. Okay, so for the orbital here, you need to draw in dumbbell. Okay, so draw it nicely. And here, you need to pair up the electron. Okay, so it will be like this. One electron from fluorine and another electron is from hydrogen will be shared together to form sigma bond. Okay, so for the 2p orbital here, don't forget to label the 2p orbital. Okay, so 2p adalah bentuk dumbbell. So keseluruhan warna biru ini adalah 2p orbital. Okay, and then this is fluorine atom. So kita akan label di tengah-tengah. Okay, make sure you boldkan the labeling. And there you go, the overlapping of hydrogen fluoride to form sigma bond for hydrogen fluoride. It is the overlapping of s orbital and p orbital here, 2p orbital. Okay. Okay, so you can see one of the 2p orbital is single electron and one s orbital here with single electron will overlap with this single electron lah. Okay, next example, you have fluorine molecule. So for fluorine molecule, let's do this example. Okay, first write the fluorine bonded to another fluorine. So you will form here sigma bond. Okay, so for fluorine atom, I'll just label fluorine A and fluorine B. Okay, so for fluorine A, okay, you can write the electronic configuration 1s2, 2s2, 1, 2, 3, 2p5. Okay, so for the second fluorine atom, you have the same electronic configuration 1s2, 2s2, 2p5. Sorry, 2p5. Okay, so you can see one orbital in 2p. Okay, there is single electron here. Okay, so it will form bond with another single electron from another atom. Okay, these two will be sharing. Okay, share their electron to form covalent bond. In this case, you will form sigma bond. Alright, so how to draw the overlapping? Okay, so you refer back. This single electron belong to who? To p orbital. Okay, so 2p orbital, you know that p orbital, the shape is dumbbell. Okay, so 2p orbital, it can be any orientation lah, 2p, x, py, pz. So for that orientation, you don't need to bother much about that. Okay, so you just draw the orbital. Okay, so first I'll draw for Fe. So one dumbbell. Okay, label in the middle here, F atom. Okay, make sure you write it clearly. And it is what orbital? 2p orbital. Okay, must label the atom. You must label the orbital. And then with one electron. Okay, so for FB, I'll draw it in blue color. And this is your another dumbbell. Okay, so draw and label the atom, and then label the orbital 2p orbital where you got the single electron from, and then pair up the electron, label the sigma bond in the middle, okay, to show the overlapping. Right. So next, let's see example for Cl2. Okay, so Cl2 is almost similar to fluorine. Okay, you will form sigma bond, but for chlorine, okay, the electronic configuration will be 1s. So you will have 1s2, 2s2, 2p6, 3s2, and 3p5. Okay, so you can also straight away write the valence first shell, second shell, and this is the valence, right? Okay, so straight away write for the valence electron. 3s2, 1, 2, 3, 4, 3p5. Okay, so this is for Cl chlorine atom, the first one, and then I will draw with red color for Cl atom for B. 3s, 3p. Okay, for the orbital overlapping, since your single electron here, it belongs to 3p orbital, and then another single electron that will be shared with belongs to also 3p orbital. So you know p orbital must be in dumbbell. Okay, so draw out the overlapping. So for chlorine A, okay, so you just need to draw it nicely and neatly. Okay, make sure the size is big and clear enough. It's easier for you untuk label nanti later. Okay, chlorine, and it is 3p orbital, yeah? And with one single electron and another 3p orbital. Label Cl, 3p, and pair up the electron. Bila dah pair up, jangan lupa label sigma bond. Okay. So next we will move to Pibond. Pibond is a covalent bond produced when two lobes of p orbital overlap side by side. It only occurs between p orbital, and usually it involves double or triple bond. So this is the example. So you have one p orbital that will overlap with another p orbital. So the overlapping will be like this, or we can represent it in this form lah. If in terms of drawing, I will show you how to draw it later. The thing that you need to know here, double bond, if you are dealing with double bond, it involves one sigma bond and one pi bond. Whereas, so for double bond, satu sigma, satu pi, ingat ya? Okay, so kalau triple bond pula, 1, 2, 3, triple bond, means ada satu sigma, 2 pi. Okay, so always remember, sigma always akan ada satu sajalah. Okay. Single bond, sigma saja. And double bond, sigma 1, pi 1. For triple bond, 1 sigma, another 2 bond is pi bond. Right, let's move to the first example, oxygen molecule. So oxygen, you have O2, but then if you do not remember the Lewis structure of oxygen, you need to do step by step. So first thing, you need to calculate the valence electron, the total oxygen. You have 6 valence electron and you have 2 oxygen atom. Total you have 12 electron. So minus 2 for bonding. You left with 10 electron. So distribute them 2, 4, 6 octet and another one 2, 4. Okay, so finish with all the 10 electron, but then you have problem here. This oxygen is not octet. So what we can do, we use this lone pair to make double bond here. Okay, so this is the structure of oxygen molecule. So one of the bond is sigma bond and another one is pi bond. So always label sigma pi at your bond here. Okay, this will be your guideline for the overlapping later. Okay, so for oxygen, so I'll name this oxygen A and this is oxygen B. So for oxygen A, you have the valence electron 2s, 2, 2p, 1, 2, 3, 4. Okay, so for oxygen B, you have also the same 2s, 2 and 2p, 4. Okay, so you can see here to make double bond here, you must have single electron, 2 single electron. So 1 single electron here will be paired up with another single electron from oxygen B. Okay, so ini kita akan form sigma bond. Okay, so the next pair dekat sini, 1 single electron will be shared with another single electron to form covalent bond, which is pi bond. Okay, now let's draw the overlapping. Okay, so first thing first, you need to start with sigma bond. Okay, so for sigma bond of oxygen, okay, so since this single electron highlighted in yellow is in 2p orbital, so 2p orbital is in dumbbell. Okay, so draw out a bigger dumbbell because later you want to show the overlapping of pi bond. Okay, so this is oxygen, your oxygen yang pertama. So this is 2p, label 2p, and you have 1 electron here. Okay, 1 single electron, and it will pair up with this single electron from 2p orbital as well. So we just draw the overlapping. And this is also oxygen. And this is from 2p orbital, and pair up the electron and then label sigma bond. Okay, so settle with sigma bond. Now, let's draw the pi bond. So, pi bond ini yang warna hijau ni. Kita nak lukis. So, for the oxygen A, so ini adalah oxygen A kan. So, you have one single electron masih lagi di 2p orbital. So, 2p orbital adalah dumbbell. So, did you still remember? Untuk p orbital, you have 3 different orientation. X, Y, Z. So you have 2px, 2py, and then 2pz. Okay, so if you separate this into each 2px, 2py, 2pz, it will be 1 you have with this orientation. Okay, and another one with a different orientation. Okay, so now we are going to draw for this kind of orientation. Okay, tak kisahlah dia px ke py ke pz. So as long as it is different orientation. Okay, so draw out yang menegak. Tapi masih lagi dalam bentuk dumbbell. So jangan putuslah. Okay, so kalau tak for drawing, you can use pencil. And this need a lot of practice. Okay, so level 2p and this one 2p yang hijau ni ada satu single electron. Okay, ini untuk oksigen A. So untuk oksigen B sama juga, lukis dumbbell. Okay, so level 2p orbital and you have another one pair of electron. Okay, so macam mana nak show dia punya overlapping ni? So you draw the bridge. Okay, dia akan overlap side by side. Masih ingat lagi? So pi bond overlapping side by side. Okay, means dia akan bertindih di bahagian atas ni sebelah this side and this side. Okay, so it is impossible for us to draw the overlapping since kita nak tunjuk juga dia adalah for the sigma bond, the overlapping. That is why we use the bridge, okay, garis satu atas dan satu bawah sepasang to show that this is pi bond. Okay, wajib label yang di sini. So settle for pi bond. Okay. Alright. So next we move to the next. Okay, the last example is nitrogen molecule. So nitrogen molecule, you have 5 valence electron and times 2 nitrogen atom, total 10 electron. So N bonded to another nitrogen, tolak 2, 8, and then octetkan one of the terminal atom, 2, 4, 6, and you will have another 2 electron, put it here. Okay, so now this nitrogen is not octet. So, jadikan dia triple bond. Next, this is your structure for N2. Write the electronic configuration for nitrogen. So, you can either write one as 2 to S2 to P3 or you can just straight away 2 as 2, 1, 2, 3, 2p, 1, 2, 3, 2p3. So this is for Na and B, still the same, 2s2, 2p3. Okay. Next. Okay, you have triple bond here. So one of them will be sigma and another two will be pi and pi. So mean you need to have 3 single electron from nitrogen A and another 3 single electron from nitrogen B to form covalent bond. Okay, so double check nitrogen A must have single electron 1, 2, 3. So 1 is for sigma, another 2 is to form pi bond. Okay, so double check with nitrogen B, 1 sigma, 2 pi. Okay, so for this 2 electron, it is in pair. So double check here. Okay, so you have 2 electron, 1, 2. Okay, mean maksudnya dekat atom kamu mesti ada satu lone pair. Okay, so untuk nitrogen B ada satu lone pair. Okay, so I always label dekat electronic configuration, Miss akan always label ini akan jadi lone pair. So ini akan jadi sigma, pi dan pi, so that I can cross check and double check with my structure and when I want to show the overlapping. Okay, so let's show the overlapping now. Okay, so first kita akan buat sigma bond dulu. So for sigma bond, kita akan buat sigma bond. First single electron is in 2p orbital. So 2p bentuknya dumbbell. Okay, you have one electron here and it is nitrogen. Jangan lupa label. So it is in 2p orbital. Okay. Perlu label dua-dua begini ke? Bukan. Okay, bukan macam ni Ini salah. Okay, you just need to label one of the lobe. Sebab apa? Dumbbell p orbital begini. So satu dumbbell ini adalah 2p orbital. Right. Next, another to form the sigma bond, dia akan overlap with another 2p orbital and pair up the electron, spin up, spin down, label the sigma bond. Okay, next. Okay, 2p orbital kita ada 3 orientation kan? Px, Py dan Pz. So kita lukis yang menegak dulu. So I'll use green color. Okay, so ini adalah 2p orbital ini for this one. 2p and you have one electron. And then dia akan overlap with this electron lah. So mesti lukis pasangan dia mesti yang menegak juga. So pair up the electron, spin up, spin down, 2p. Okay, so for your example ini kamu boleh guna dalam different color lah. Tapi kalau dalam exam, kamu akan guna pen saja. Okay. So untuk nota, for notes purpose, okay, you can use highlight ataupun pen yang berwarna-warni. Okay, so don't forget to draw the bridge untuk indicate sepasang garis di atas dan garis di bawah and label the pi bond. Okay, so settle for pi bond yang pertama. Sigma bond pun sudah. And then last kali pi bond yang seterusnya. Okay, so remember p orbital ada px, py dan pz. Okay, untuk buat dia punya overlapping mesti yang sama side. Okay, kalau yang end to end, pasangan dia mesti end to end juga. Okay, kalau menegak begini mesti menegak juga partner dia. Okay, macam ni. Okay, another orientation you can use is yang sengit ke tepi. And the overlapping partner yang di sebelah mesti sengit juga. Begini. Okay. Now I will show you with purple red color. Okay. So draw the 2p orbital and then one single bond, Okay, partner dia mesti parallel begini. Okay. So that is why your drawing kena besar. Supaya senang untuk kamu melukis and show the overlapping. For the drawing, you need to practice a lot lah, especially untuk Pibond. Okay, so don't forget to draw bridge. Satu atas, satu bawah. Okay, mesti touch the lobe and label pi. Okay, bukan label atas dan label bawah begini salah. You just need to label one side. Okay, sebab tu kalau my style, I will label dekat mana yang ada elektron tu, pi. And then ini dekat sini pi. Oh, sorry. Okay. Next, for the next part of 4.3, kita akan masuk hybridisation for the next tutorial.